For the second part of this lesson, we're going to learn how to do a confidence interval. So you're given the formula for a paired t interval. It starts with x bar of the differences plus or minus some t critical value times standard deviation of the differences divided by radical n. So we're going to use the same data that we used in the last notes. Okay, so I'll let you guys enter in that data. Now's a good time to pause the video if you don't still have this data. So I have pretest in L1, post-test in L2, and in L3, I did L2 minus L1. Okay, so the conditions are the same as for the test. So I'm not going to write those again. You guys can pull those from your 11.2a notes. So right after the conditions, you're going to write, since the conditions are met, we can use a student's t-model. The number of degrees of freedom is the number of pairs minus 1. So we have 12 students, so there are 11 degrees of freedom. To compute a paired t-interval, so before showing my work, I'm going to run the interval on my calculator. So I go to Stat, Tests, and should be number 8. We have data, and my data is in L3. My frequency, I don't have a frequency list, so I'm going to leave that as 1. We want a 90% confidence interval, so C level is 0.9. And then we're going to calculate. Okay, so showing our work, we get that X bar is 144.583 plus or minus, and then we have to put in a T star. So inverse T. So I'll fill that in later. T star, and then standard deviation would be 109.74 over radical n, which is radical 12. Alright, I'm going to write down the interval as well while I'm here. So this is going to be 87.691 to 201.48. And if you got the same thing but negative for both numbers, that's also correct. It all depends on which way you subtracted to find the difference. So now I'm going to find my T star. So to do that, I go to second vars to get to distributions. And then number 4 is inverse T. And the area I want, so since this is a 90%, if 90% is in the middle, there's 10% in the tails, which means there is 5% in each tail. So I'm going to do 0.05. My degrees of freedom is 11. So this equals negative, or it doesn't matter, you could put the negative or positive value, negative 1.796. So that goes here. And it doesn't say to interpret, so we are done with this problem. So we have one more example on the back. One indicator of physical fitness is resting pulse rate. 10 men volunteered to test an exercise device advertised on TV by using it 3 times a week for 20 minutes. Their resting pulse rates in beats per minute were measured before the test began and then again after 6 weeks. Results are shown in the table. So remember, with paired t-tests, we don't really care about the original data. We only care about the differences. So you could put the data in L1 and L2 and then subtract them in L3. On this one, it looks easy enough to just subtract it mentally. So I'm going to do after minus before. That way, if it's positive, it shows improvement. So the first one's 0. The second one, it got worse, so negative 4. This one also, I shouldn't say it got worse, it got lower. This one also went lower. This one went up by 1, and this one went down by 3. So clearly the average is going to be negative. So now I'm just going to put in the difference column. Stat, edit, and I'll go ahead and put these in L1. Okay, the first step is to check conditions. So I'll do that up here where I have room. Okay, condition 1 is that the sample is either random or representative. So we have 10 men who volunteered. So I guess we'll just have to assume that they are representative of the population. Okay, and notice they only used men, so that's an example of direct control. Second condition is either satisfied by the CLT. That won't work for us because we only have 10 pairs of data. So looks like we're going to have to use one of the plots. So I'm going to use the normal probability plot, and I see a diagonal straight line. A normal probability plot of the differences. shows a roughly diagonal straight line. Indicating the population is approximately normal. Condition 3 is that the data are paired. Right, since all three conditions are met, we can use a student's t-model. So they did the before and after results for 10 different men. So we have 10 minus 1, 9 degrees of freedom. And we're going to compute a paired t-interval. So let's compute the interval on our calculator before showing our work. Stat, tests, t-interval is number 8. I have data, mine is in L1, frequency, leave as 1. We want a 95% confidence interval, so 0.95 for sea level. Calculate. Okay, let's show our work. First thing I need to do is inverse t. So if it's 95%, I want 5% in the two tails, or 2.5% in each tail, and I have 9 degrees of freedom. Alright, I'll find that later. So x bar is negative 2.8, plus or minus. I'll leave a gap for the t star that we'll find later. Standard deviation is 2.53 over radical 10. And the interval we're told is negative 4.61 to negative 0.9903. So now let me find that t star, second vars, to get to distribution. Inverse t, 0.0259. This equals negative 2.262. And it doesn't matter if I put the positive or the negative. They didn't ask us to interpret, but if we needed to, we would say 85% confident that the true mean difference in pulse rates before and after using the exercise device is between -4.61 and -0.9903.